Hi everyone, Mr. Eric Kua here, founder of Mr. Khemistry. Hope you're enjoying the videos that I've made for you specially. Remember to tap that like button and to click subscribe and to share with your friends if you found any of these videos useful or interesting. I look forward to seeing you around. Let's get started with today's topic. Hi guys, so today we're going to talk about how to answer, right? The question, explain why transition metal complexes are usually colored. Okay, let's get down to it. There are altogether 3 points that you have to put in for your answer. The first point, right, has to do with the d orbital splitting. So the key phrase is, of course, the splitting of d orbitals in the presence of ligand, because there is some sort of electronic repulsion. So this is the first point that you need to put into your answer. This diagram here is entirely optional. This is basically for you to basically understand it better. Okay, you do not have to draw this diagram in, just to visually let you see what happens. Okay, the second point that you need to put across in your answer, right, is that you got to tell the examiner that you understand that the d electrons undergo this process called d-d transition. Okay, d-d transition, whereby the electron is promoted from a lower energy level to a higher energy level. Okay, so this is denoted by this blue arrow over here. Okay, the last point that you need to put in, right, for your answer is the reason why transition metal complexes are colored is because when this d-d transition takes place, right, the d electron undergoes the transition, absorbs energy from a certain wavelength. Okay, certain wavelength of this electromagnetic spectrum, and the complementary color that is not absorbed is seen as the color. Okay, the complementary color, meaning the color that is opposite on the color wheel. All right, so for your answers, right, for the A levels, you kind of got to customize your answer to answer the question itself. Okay, so basically, let me continue showing you the example, right? So this question from 2011, they want you to outline the origin of red color. So specifically, right, you got the answer to this particular question of the red color. Okay, the metal complex here is iron complex. So in the presence of oxygen ligand. So you notice that we are customizing our answer to answer this question context. So we have the iron as a metal complex. We have the water, O2, right? Oxygen as the ligands. Okay, the rest of it is pretty much similar, except the last point, and then again we zoom in to answer the question, right? It absorbs a short wavelength. So this is in relation to the particular question. Okay, and then they say it absorbs the light from the blue region. Okay, and emits the remaining wavelength, which the complementary wavelength, right, which appears as red color. So you see the points which I've highlighted, right? These are customized to your question. So this is something that you got to learn as an A-level student, as opposed to just memorizing, right? Memorizing the script. Okay, can you just answer the question using this generic answer? Yes, you can, but you probably have some marks deducted because you're not customizing your answer. All right, guys, hope this helps.